Okay, let's do another example. So it says verify Stokes Theorem when f is negative yzi plus xzj plus 0k, and s is the intersection of this sphere and z greater than or equal to 1 over square root of 2. Okay, let me first state Stokes Theorem. So here's Stokes Theorem. It says the line integral of f around the boundary of s taken in a positive orientation equals a flux of the curl of f across s. Okay, so let's now graph the s region in this example. Oh, also, I'm going to, when I verify Stokes Theorem, I'm going to work on this side first. So let's draw the surface they're talking about here. Okay, so the x squared plus y squared plus z squared equals 1 is a sphere. I've drawn half the sphere here because we have the condition that z is greater than or equal to 1 over square root of 2, which I'm calling alpha, which I put here. So here's my x-axis, my y-axis, and z is coming up this way. So I put my alpha on the z-axis. So therefore, it's going to be the portion of the sphere from alpha and above. So let me draw that. So it looked like this, my surface. So it's the top piece of the sphere where the z value is greater than or equal to alpha. So it's this piece up here. Now let's parameterize this. Well, since it's a sphere, since it's a portion of a sphere, we're going to use spherical coordinates. Okay, here my rho value is 1. So let's use spherical here with rho being 1. So I have this then. So there's my spherical coordinates. So again, the rho is 1, so you're going to have a 1 in front of these guys. That's my spherical coordinates for x, spherical coordinates for y, spherical coordinates for z. But z has the added condition that it's greater than or equal to 1 over square root of 2. So I can then solve for phi by taking inverse cosine on both sides. Let's do that. So taking inverse cosine on both sides here, I'll have then my phi angle is inverse cosine of 1 over square root of 2. And if you check that in your calculator, that's pi over 4. So pi over 4. So then the theta angle, since it's going around here, is going to go from 0 to 2 pi, and the phi angle is going to go from 0 to pi over 4. So let me write my R mapping right here. So what I have this then, so this would be my R mappings. That's your x, y, and your z, and your conditions on theta would be from 0 to 2 pi, phi would be from 0 to pi over 4. Okay, so let me graph my D region right here. So my D region would be this rectangle from 0 to 2 pi on the theta axis, 0 to pi over 4 on the phi axis. That map under R into my portion of the sphere from bigger than alpha, where alpha here is 1 over square root of 2 on the z. Okay, so let's start now to do the double integral part of Stokes Theorem. So summarizing, we have this is our parameterization of our surface. Here's my f function, and I want to do the this double integral. I know this double integral will equal this. Okay, so it requires us to find r derivative respect to theta across r derivative respect to phi, and we also need to find the curl. So let's work on the r derivative respect to theta and derivative respect to phi first. So let's do that. Okay, so r derivative respect to theta. Well, derivative of cosine would be minus sine, and that just stays, so it'll be minus sine phi sine theta. Then this one over here, derivative of sine theta would be cosine theta. And derivative of cosine phi with respect to theta would be 0 because that's just a constant, so it'd be this. Okay, let's do now derivative with respect to phi next. So derivative of r with respect to phi, so derivative of sine phi would be cosine phi, then cosine theta. And that'll be on again cosine phi sine theta, and derivative of cosine phi to be minus sine phi. Okay, now let's cross these. So here's my definition of cross product. So I have my R theta guy on the second row and R phi guy on the third row. Now to simplify things a bit, notice here on the second row I can pull a sine phi actually outside. So let's do that. Okay, so I factored out the sine phi in the second row, so I have a minus sine theta, cosine theta 0 then in the second row. So let's do the I component. So it'll be cosine times minus sine minus 0 times z. So let me write that here. So look at this. So again, it's cosine times minus sine, which I have here, then 0 times that just be 0. Let's do the J1 next. So it'll be minus sine times sine theta times minus sine phi, and it'll be 0 times that. So let me write that down here. So I get this. Actually, I noticed in the first one there should be an I, not a J. So it should be I here. Okay, so I went negative sine theta times minus sine phi here, and then 0 times that, which is 0. And there's a minus sign in front for the J component. Okay, and let's do the K one. So it'd be minus sine times this minus cosine times that. So let me write that down here. Oh, I just noticed something. My sine phi should have been over here too, so let me just add it up here. It's going to be in front of everything. Okay, then I did my K1 here. And now going sine phi times sine phi squared, and you got a cosine phi. I pull a minus sign out here, and then cosine times cosine phi, cosine squared, and a cosine phi. I'm going to factor out the cosine, negative cosine phi down here. So let me do it. So again, the ones I've underlined, negative cosine phi, I'm going to factor out. So let's do that. So factor out the minus cosine phi. Then you have a sine squared, cosine squared here, that's 1. Okay, so let me simplify things then and write out our final answer here. So simplifying, so we have the cosine phi all the way in front, then here just be minus cosine sine for I component, then 3 minuses will be minus, will be then minus sine theta cosine, sorry, sine phi, and last one will just be, that's 1, it's going to be minus cosine phi. Notice all three of a minus sign here. I'm going to pull that minus sign out and put it in front over here to make it look nicer. So let me factor out the minus 1 then. So I factor out the minus 1, so you got minus sine phi, this stuff then. Okay, so let's summarize now. Let's put that at the top, and let's find now the curl next. So summarizing way of this then. So I just noticed actually that should have been a phi below. I had a theta there. It should be a sine phi right here. Okay, everything else looks good. Now let's do the curl next. So here's my f up here, so let's do the curl. Okay, so here's the definition of curl. So I have my del operator on second row. Then I have my f function, the components. So it'll be minus yz here, xz here, and 0 here. Okay, so let's start doing this. Let's do the I component first. So it'll be partial y operator acting on 0 minus partial z operator acting on xz. Let me write that here. Again, I have my partial y operator acting on 0, then minus partial z operator acting on xz. Okay, so I've done here. Now we'll do the J1 next. It's going to be partial x operator acting on 0 minus partial z operator acting on negative yz with a minus sign in front. So let me write that over here. Okay, so we get partial x operator acting on 0, which I have here, then minus partial z operator acting on negative yz with a minus sign in front. Okay, then we'll do the k component. So partial x operator acting on xz minus partial y operator acting on minus yz. Let me write that here. So I get this then, so partial x operating on xz here minus partial y operating on minus yz here. Okay, so let's write these results out then. So that's going to be 0 there for that one. That's going to be negative x. So it's going to be negative xi. So So I'll write that here. And then moving on to the next one, that's going to be 0 there, and derivative of negative yz with respect to z would be negative y, but you got 3 minus signs, so it'll be minus yj. So written that here. And last one, partial derivative with respect to x of xz would be just z, and this derivative with respect to y of this guy would be minus z, but you'll have another minus sign in front, so it's actually going to be 2z when you add those. Okay, so this is our curl right here. Okay, so let's summarize. Okay, so summarizing, I put my curl up here. Okay, so now we're ready to do the double integral. So our double integral over s will equal double integral over d of this guy here. Okay, so when I plug in to the curl, and my x will be this guy, my y will be this, my z will be this. So we label them here x, y, z. So I'm going to plug into this then. So let me write what you get when you start plugging into this. My d region again here is from 0 to 2 pi, 0 to pi over 4. Okay, so let's start plugging in. So I get this. So again, how I got this was it's my curl is negative xi, but x now is sine phi cosine theta. That's I. Then minus yj. Y now is sine phi sine theta. J 2 times z. So it'll be 2 cosine phi. Oh, it should be k here actually. K. Then dot it with my r theta cross r phi, which is right here, which I've written down here. So minus sine phi cosine theta sine phi I plus sine theta sine phi j plus cosine phi k d theta d phi. Now we're going to do this dot product. So we're going to multiply the I components, the j components, and the k components. So let me do that down here. So dotting, I get this. So for example, the I components, I got a negative sine phi here, and a negative sine phi here. So it'll be then sine phi cubed, and you'll have a cosine times cosine, so it'll be cosine theta squared for the dotting the I ones. Dotting the j ones, you'd have a negative sine phi here, here, and here, so it'll be 3 of them. But 2 minus signs, it'll be sine phi cubed there, and you got a sine theta, so sine theta squared there, and then you'll have a 2 cosine phi squared and minus sine phi, so you get this. And notice on these two right here, they have a sine phi cubed in common. So let me factor it out. I'm not going to write another line, I'm just going to factor out right here. So let me do that. So factoring these out in front. So I factor it out in front there, and then you have cosine theta squared, sine theta squared, that's 1. So then what's left is, this doesn't have a theta, this doesn't have any thetas, they just have phis. So when you integrate, they'll be treated as constants now, so let's integrate. So again, integrating the sine phi cubed and the 2 cosine phi squared and sine phi are like constants, so when you integrate, you just put a theta in front there. Then going to evaluate a 2 pi and 0, so you just put a 2 pi here. I can bring that 2 pi outside the integral then, let me do that. So pull the 2 pi out here. Okay, so now we need to integrate this. To integrate the sine cubit, we're going to have to make a substitution. So we're going to write it as sine times sine squared, and then replace the sine squared with 1 minus cosine squared. So let me do it. Okay, so I replace the sine phi cubed with 1 minus cosine squared, cosine phi squared sine phi. Again, because I can break the sine phi cubed down as sine phi squared times sine phi, and the sine phi squared I can replace at 1 minus cosine phi squared. Okay, so I'm out of space here, so let me erase some things and write it up here now. Okay, so I wrote it up here. So now I'm going to make a u substitution. I'm going to let u equal cosine of phi. So let me do that over here. So letting u equal cosine phi, then du the phi is going to be minus sine phi. Then solving for negative du, because I have sine d theta here and here. So negative du would be then sine phi d theta. D phi, sorry. So let's make these substitutions into this. So making the substitutions, we get this. So I distributed d phi to each of these. And then sine phi d phi is negative du. So I have negative du on that one. And negative du here. Okay, so u of pi over 4, well, you have your u is cosine phi, so it would be cosine of pi over 4, which is 1 over square root of 2. And u of 0 would be cosine of 0, which would be 1. Again, I can now turn this limit around here, because this is a smaller number than this one, introduce a minus sign, which will cancel those ones out. So let me rewrite it here. So turning around, introduce a minus sign, I'll make those positive. I pull out a du over here now. I can combine the minus u squared and the 2u squared. So let me do that. So we get this. So now integrating this guy. So integrating 1 over u, integrating negative 3y squared would be negative u cubed. That's it. So we'll get this. So I'm going to evaluate at 1, then subtract evaluate at 1 over square root of 2. So let's do that. Okay, so putting 1 in place of u, then subtracting, putting 1 over square root of 2 in place of u. I'll get this first guy. Then minus, then putting 1 in place of u cubed. I've got 1. Subtract, put 1 over square root of 2 in place of u cubed. Get this. In place of u, sorry. So we'll get this. So simplifying this. Okay, so simplifying, then 1 minus 1 they'll cancel. Then it'll be minus 1 over square root of 2. Then it'll be minus will be plus there. And 1 over square root of 2 cubed is 1 over 2 square root of 2. Get a common denominator, simplify, got negative pi over square root of 2 as our answer. Okay, so we've done one side of Stokes Theorem. And I'm going to leave the video there because it's getting kind of long, the video. So we'll do the line integral part in part 2 of the video, and we'll show it the same as this. So let's leave it there.